Hey there, IT 145 students. So in this recording, we're going to go through the idea of inheritance in Java. Now, in previous assignments, you've already been exposed to the idea of inheritance. So we've been working with UML diagrams that have a base class that contains some common fields for derived classes. And so in our case, the example's been the pet class, where all the pets have a name, and then the cat class versus the dog class might have some different fields to them. So in this recording, we're going to look at a grocery store inventory system where we might have a class like a generic item, where every object in the system has a name and a quantity, and then we want to extend the functionality of based on what other fields an object might have. So in this case, we might have a produce item. Again, it's going to have a name, it's going to have a quantity, but the new field that it's going to have is an expiration date. So the last thing that we want to do is copy and paste all of the commonly shared code in different classes. So, right, we could have a produce item, but we could have, say, a meat item. And a meat item still has an item name, still has a quantity. And if we don't use inheritance, we have to copy and paste all of that code. Well, if we ever need to change that code, we didn't have to go find that in every single place that we did that. So the idea that we want to do is we're going to create a base class, in this case, generic item. It's going to contain all of the common fields and then all of the common methods that we want to have. And then we're going to extend that class, and then the produce item will get all of those fields, plus we then add additional functionality. So in this case, we're going to add an expiration date to it. So again, some terminology to be familiar with. We have the derived or a subclass. We have a base class, or we also refer to it as superclass. You might also hear the terms children class, parent class. So be familiar with those three sets of terminology. So the idea here is our base class contains the common functionality. So we define it as a class. We've got an item name, quantity. They didn't provide a constructor. They've got the setters here. We didn't provide any getters. We did provide a print item method here. And then we have this produce item. And in inheritance, we use the extends keyword and then the name of the class it is extending. So keep in mind, I don't copy and paste the item name and quantity down here. I will get those fields. I'll have access to things based on the inheritance of this class. And then again, you can see that they have the expiration date, and they did provide methods to interact with that expiration date here. So again, we had a produce item, but we could potentially have things like a fruit item that it could actually extend a produce item, right? Fruit is a type of produce. But something that's not a produce item could be a frozen food item, right? It still has a name, it still has a quantity, but what's going to be different about it? Well, it's going to have a UPC code, it's going to have a frozen food section that it's in, so things that differentiate it from being the other types. They also go through a business and restaurant example. I'm not going to go through that just because we're going to kind of see the same ideas with the produce and grocery items. So let's talk about in our derived class. So one thing that keep in mind here is we still have member access to our variables. Now, previously we've been introduced to the private and public keywords. Keep in mind, private it is only accessible within this class. So from this curly brace to this curly brace, you only have access to that variable. Or if it's a method, you have access to that method. If it's public, anybody can have access to it. So in inheritance, those rules still apply. If I declare name and address as private, if I try to access those variables in the inherited class, I'm going to get an error because I don't have access to a private member variable. So in order to access them, we could potentially make them protected as a new keyword. So protected gives it access to the classes that extend from it. So again, we wouldn't want to make fields ever public because anybody has access to them. So a workaround for that is to use the protected keyword, which is what they talk about down here. So they're going to define this business class. They're going to make the name protected, which means anybody that extends this class has access to that variable. However, they kept the addresses private, so it can only be manipulated, set, and worked with in this class right here. So where would you use this? Always keep in mind, what scope of variables do you need? To be honest, most of the time you're going to have your common fields in an inheritance situation as protected. You're probably going to want access to them potentially in the other classes that extend it. All right, so before we go in there, let's go ahead and kind of take a look and see how all this all works. So I've copied the code for the generic item. So again, we've got the item name, we've got the item quantity. The produce item, we have the extends keyword, and then we added the functionality of the expiration date to it. And then they have a little driver here, so a main method, where they're going to create a generic item. They're going to create a produce item, and they're going to set the generic item. It's a cereal. They've got 9 of them. The perishable item has the name of apples. There are 40 of those, and they provided an expiration date for that as well. So when they run this, so they're going to create the miscellaneous item, and then they're going to print its details. So its details, name, and quantity. And then they call the apples one that's been created, and you can see that it's got its name, it has its quantity, and then the additional detail is that they then print the expiration afterwards. So print item is common. It's in the generic item class. So it just takes the item's name, quantity, and concatenates it. So we've mentioned in methods that we can have overriding and overloading. So overriding a method says that we're going to take a base class method, we're going to copy the signature exactly, and we're going to provide a different implementation of it. And so for the business example, we might have a get description method. And then in the restaurant, which is a type of business, we might override that method and provide a different implementation of it. Now, the at override annotation is a helper convenience. It's not required, but it does tell other programmers that you overrode the base class's implementation. So we could do the same thing in our produce item. So we have a print item method. So we could copy that. We could paste it. Now keep in mind, remember, we don't have access to item name and item quantity. So what we could do here for now is print the expiration date, which is something that we have access to. Again, the at override annotation is not required, but again, it's helpful to let other programmers know that you've overridden the base class method's print item. Now, if we try to have a parameter, okay, so this is a different signature than the one in generic item, okay, this doesn't take a parameter. And now it's going to say you're trying to specify that this overrides something that doesn't exist. So it has to match the signature exactly. So overriding, again, we'll see in an example here in a second how we can handle the fact that the name and address are potentially private or not exposed to us. The overloading method, again, we saw in methods, overloading means I have the same method name, but their parameter types are different. So when we went with this would be an example of overloading, where we're going to potentially have a method with the same name, and we might provide it some different values. So we might make one with an integer value, we might want to have one that takes a double, and so forth. But anyways, for now, keep in mind that the overriding that we're talking about is going to match the signature exactly. Okay, so if we want to really override this method, we really want the functionality of the parent. And keep in mind, they've chosen to make this private, so let's keep with that this is being private. So how can we access and get the print statement that they had before? Well, we can call a base class method using the super keyword. So we can ask for the base class's initial method, and then we can add to it. So for instance, we can call super dot, and then look, I've got all of the things that are publicly available or protected. So I can call the supers print item, which will print out the item's name and quantity. And then here, we'll then also, if I could get this to line up maybe, we'll then also print out the expiration date. So let's go to the class example here, and they have this implementation. So we'll go ahead and just comment that out. And let's go back in here and we'll put expires, and there we go. So let's run this. And so again, here's the generic item. We get its details. And then right there, we call print item. We get the base class, and then we get the child class extra value. So again, if we don't have direct access, we always have access to the public things using the super keyword. Next thing in section 4, they talk about the object class. So one thing to understand about the Java programming language is that every non-primitive type, so remember primitive types are like int and double lowercase letters, well, everything extends from the object class. And every object has a toString, has an equals method. And it's very common that we override the toString and equals methods. So let's just go ahead and come in here. I'm going to let the IDE do this for me. So if I right click, go to source, generate, I'm going to do hash code and equals, and I'm going to let it generate an equals method and hash code based on these fields. Select all, generate. And so what this is going to do is it's going to check if two generic items are the same. And they eventually, so we've got some other details down here. Don't worry about those for now. Just leave those in there. But eventually it checks if the item name of this object and the quantities match up. And if that's the case, then we're going to say they're the same item. But really, we probably just want to use the item name. We don't care about the quantity. So I'm going to get rid of that. We also want to provide a toString method. So source, generate toString, and I'm going to let it include these two fields, generate. And so this is going to provide a very useful representation of the data. Like they point out here, if you don't have a toString method that you implement, then you're going to get something that looks like this, where you're going to get its data type and @ annotation, and then this hex code is very similar to its memory address. It's not meaningful to us. So always, always, always imply a toString method. And then it's also recommended to, if you're ever going to check if two objects are equal, apply the equals method, and then also provide a hash code. All right, so let's go into the produce item. And this time, keep in mind, it is going to extend. So we're going to generate hash code and equals. And let's see if it automatically, usually they'll ask us if we want to call the super method. Let's see if it automatically does it. And yes, it does right there. So it calls the super, so it calls the parents class hash code and then adds to it. And then you can see in the equals method, it calls the supers equals method and continues on. And then we have our own where we check the expiration dates. So let's talk about this. For a produce item, really the only thing that makes them equal is, again, the item name, right? So while we can override these methods, I don't think we need to include the expiration dates. So let's just go ahead and comment that out for now. Maybe for this example, we just want to have the names being the same. We do want to provide a toString method. So source generate toString. And again, we're going to have the expiration date. And again, sometimes it'll ask, do you want to call the super? And we'll see if it does that for us. It did not call the super. So really, we would want to call super.toString. And we're going to clean this up a little bit. It's going to look a little ugly. Let me go back there. Hold on, I'll be right back. So again, if we kind of provide calling super here, what's going to happen is we're going to say generic produce item. We'll make these side by side. So we would see generic item and then get its details. And then it would say produce item. So I don't think I really want to do that. So let's do this. Let's make this protected. Let's make this protected. So now I have access to it. Let's see if we can let the IDE regenerate this. Source, generate toString, and here's the inherited fields. So let's see what that looks like. Generate. And so now we have the produce item. It's got its expiration date. And then look, we also get the item name and item quantity. Again, because we made those protected. Okay, so that gives you a couple ideas about how we can use some object methods. Next section that we're going to talk about here is polymorphism. And I know in previous assignments, they've kind of introduced the idea of polymorphism. But now let's actually kind of see how that works. So the idea of polymorphism is that an object can take on different forms, and we can create methods potentially that handle different forms. So we might create a list that takes a generic item. And again, we've seen lists before, but what we have with this inventory list, the idea of polymorphism is not only can it take in a generic item, but it can take in anything that derives from generic items. So I can add a generic item to it. I can also add a produce item to it. So I've got the code already in place. So right here, they create that list. They're going to create a generic item. They're going to create a produce item. And then look, to that list, they add a generic item. They add a produce item. So keep in mind, I can put in anything that is a generic item or extends from it. Now, if we had, say, I'll just create so if I have an integer, okay, so that's not a produce item. So I'm going to use a capital I integer. The number equals 5. And if I try to add that to the list, we're going to get a syntax error. Okay, it's going to tell us that the number is not applicable type. I have to put in something that is a generic item. So if I created a different generic item type, I could add that to my list. Okay, so that's kind of idea number one about polymorphism, is that I could create lists that take on any type. Another example of polymorphism is that I can create methods that take on many different forms. And so this right here, this is a polymorphic method where I can give it anything that extends or is a generic item. And I'm just going to simply call its toString method. So I'm going to comment out their printing right here. Actually, I'm going to do this. I'm going to comment that out, and we're going to do this. We're going to call do something, and I'm going to give it the inventory list.get I right there. So this will get the item from the list, and it's going to send it to this method right here. Remember, everything in here is a generic item. I'm going to comment this one out for right now. And so let's run this and we should see our two items getting printed out. Cross your fingers. And there it is. We've got the, oops, I ran the wrong one. Sorry. I want to run this one. There we go. So I've got Smith cereal. I've got 9 of them. I've got the Apple, 40 of them, and it's got May 5th right there. So we printed those out. And then look, I get the exact same details. It is printing them out right here in this loop, calling this polymorphic method. Again, I can send it anything that is either a generic item or inherits from generic item. So watch this. Let's say that we have a method that takes a produce item. Okay, so let's do the exact same thing. Let's comment out this method. Let's comment this out. There we go. And you can see that we have a syntax error because this one is saying that it's not applicable for something that is a generic item. So when I get an item out of this list, it is a generic item. Now, some of them are potentially produce items, but this compiler is saying they are not all produce items. They could be a generic item. So I cannot work with this method right here because not everything is a produce item. So the example of polymorphism is right here. I can send it the base class, and everything in this list is guaranteed to be a generic item. Okay, so again, I know the idea of polymorphism is sometimes difficult to understand. Keep in mind the two main instances you need to understand are creating lists that represent multiple types, and then creating methods that handle the base class as well. Okay, so that's going to do it for this recording. As always, if you have questions, make sure that you reach out via email. I'll talk to you next time.